So today I will be talking about creating an open source MySQL firewall. And I will start with this problem and solution. So what's the problem? The problem is SQL injection. And no SQL injection talk will be complete without this classic XKCD comic about little Bobby, who is actually doing an SQL injection. Bobby drop tables. So I will be going to demonstrate a really horror case of SQL injection. And one of the solutions that we will talk about is SQL firewall. It's pretty much the way how we can protect MySQL. So let's start with this. Let's create a simple app. I want to create a bookshop. And I will use the modern approach for this bookshop. Python for our language, MySQL is a database, API, JavaScript. So in this bookshop, I will use JavaScript for the front end, which will call API, which will in turn use Python to access MySQL. I have been searching in internet for a sample of the code, and I have created this purposely vulnerable API to demonstrate it. So what is bad here? Well, this is really bad. So what happens here is that we're taking the input from our user and place it directly into MySQL. So that is really bad. What will happen then is we can use SQL injection. Now, the worst part about this SQL injection is that it's so easy and so easy to execute. We don't need any tools. We can just use the URL to put anything we want there. So in this example, I just do 1 or 1, which will basically omit any other filters that I may have and dump everything from the MySQL. Well, you may say, well, this is a public API anyway. So what's the problem? Well, the problem is that our old Bobby drop tables will actually be able to drop table. And this is not good. But sometimes even worse is that a hacker can actually take over the whole MySQL. And we can actually do this union trick to dump all the users and passwords and basically do whatever we want. We can download the whole database, and if this contains PII information or PHI information, that's very bad. Now, this whole thing is because SQL is so flexible. And this is very good, but it's also dangerous in this case. So how do we actually download and crack MySQL passwords? Well, there is a tool for that, and the tool is called SQL Map. That's a very powerful tool for penetration testing, for security penetration testing, and it is very easy to use. So let's give it a try. What I want to do here is I want to download all users, download passwords, crack the passwords. The only thing I need to do is to pass those parameters to SQL Map, specify my endpoint, this is my test private network, and then specify the URL. Okay, so now what happens is that you can see that this is actually injectable. So it found the way to inject, to do the SQL injection. So what is next? The next is it will show us what the type of SQL injection I can use. And now the scary part. It actually was able to download the MySQL passwords and crack it. So these hashes are crackable. So we have figured out that this website was using a root user with a password MySQL. So this is also bad. So let's take a look. Summary, what went wrong? First is non-sanitized input. We trust our users too much. We take whatever we're getting from the user and put it directly to MySQL. That's bad. Second is we are using a root user with all privileges, including the system MySQL database. The whole reason why we could have executed this SQL injection and downloaded the users and password is because we're using the root user. And simple password, which were cracked easily without the need of any expensive hardware or whatever. Finally, I think that this case is basically relying too much on MySQL network protection. Keep in mind that MySQL network was not exposed at all, right? MySQL is protected. We are using the public endpoint to download everything. How do we protect? And my suggestion here is we need to use all. First of all, we definitely need to sanitize our input, and it is a good idea to use prepared statements. To sanitize input, we can use whatever available in your language. For PHP, for example, there's a MySQL real escape string, which will do some job to remove escape characters and sanitize the input. The second important thing is grant only needed permissions. If you have a database, a customer database, then it's much better to grant all on that database only rather than grant everything on star.star. And finally, it's a good idea as a secondary protection to use a firewall. And you can use the application, the wide area firewall, or you can use an SQL firewall. And after this long introduction, I will present the case of building an open source MySQL firewall based on Proxy SQL. I have also created this very simple website, which I put some information there, and the slides will be available there as well. So what is Proxy SQL? If you're not familiar with Proxy SQL is a proxy, a man in the middle, pretty much, which sits behind your application and MySQL. Because of that, Proxy SQL can do things like rules, routing, and filtering. We are interested now in the security features of Proxy SQL. So starting with Proxy SQL 2.09, there are two interesting security features available. The first is SQL Injection engine, which is supposed to catch the SQL injection automatically. And the second is Firewall Whitelist. So the firewall was inspired, the implementation of Firewall was inspired by MySQL Enterprise Firewall, which is available in 8.0. And Proxy SQL has created the open source version of that pretty much. So Proxy SQL has a way to configure by both config file and SQL layer. If we want to enable those two security features from the beginning, from the start, we will use those two MySQL variables. It's called MySQL variables, but it's really Proxy SQL variables. The first is automatic detect SQLi, and the second is firewall whitelist enabled. If you are not familiar with Proxy SQL, the main way to configure proxy is to use MySQL command line and connect to the admin interface. Here we are using a local host, and we are using the specific admin port 6032. We use username, password. And here's a quick example of what we can do to display some information and to configure Proxy SQL. I will not talk about how you actually configure Proxy SQL, how you display the information apart from the security. There are lots of information how to do the routing with Proxy SQL, but again, we are interested in protecting MySQL and creating a firewall. So let's start with the SQL injection detection. Well, the good news is that it is automatic or even automagic, and it's easy to enable. But there is a big disadvantage: false positives. Unfortunately, the SQLI detection is blocking normal queries like select star from user or something like that. So there are so many false positives that it is really almost not usable. It is possible to remove those false positives, some of them, but I was not satisfied with the way how automatic SQLI detection works. And in reality, it is really hard problem to solve. We are trying to detect something that we don't know about. We don't know anything about the application. We're trying to detect it automatically. So if automatic SQLI detection doesn't work, what does? So let's take a look and let's try out and test Firewall. We will use Proxy SQL for that firewall. So let's change our app. So we will connect to Proxy SQL. Again, Proxy SQL is man in the middle. We will change our database host from MySQL master, where I was connecting before, to Proxy SQL. And then the Proxy SQL use its own port, and this is MySQL port, pretty much, as opposed to admin port. Now, what's our course of action with a whitelist, with a firewall which will use the whitelist? We will have three things to do. First is train. We'll need to create this whitelist pretty much. So the first thing that we will need to do is to collect all good SQL queries. We will collect the digests of the queries because Proxy SQL actually can generate the digest. And then out of that digest, we will create a whitelist. It's basically a rules. Then the second phase is to test. So we'll set the mode to detecting, and we'll check the error log. At the second phase, we are expecting to see some warnings. So at the detecting phase, what happens is that we say, okay, this is the set of the whitelist queries. Everything else is not good. But we are not ready to just block them yet. We just want to see what happens. And then after we are satisfied with our test phase, we can actually use the protect mode. We will disallow everything except for our whitelist. And we will do that by just setting the mode to protecting. Here are some examples. If we want to enable the firewall, again, we're using Proxy SQL admin interface. We will just set that. We can set the mode to detecting or to protecting for all users or to specific users. And this load to runtime is a way how we'll save configuration in Proxy SQL. So let's take a look. Again, this is our endpoints, our API endpoints, and we are training. So I'm visiting this website pretty much, and then I see the results. Then what I can see here is the queries. Here's the probably better slide to display the SQLs. So we are looking into this table called stats, MySQL Query Digest, and we are seeing digest text and generated digest. So after we trained it, what we will need to do is we need to load. We will need to create the firewall whitelist rules. So what we're doing here is we are loading our generated digests to the whitelist rules. And then we can select from the whitelist rules and see that those are loaded. Okay, that looks good. So let's see what happens next. So then we will want to set the mode to detecting. Again, this is horrible practice, but we're still using user root, but we will be protecting this user. So now we'll do this load MySQL firewall to runtime, load MySQL variables to runtime to enable the whitelist, the firewall whitelist. So now we will be going to the website and try to do the SQL injection. The injection actually succeeded, but we will see in the Proxy SQL log, in the error log, that it has identified the digest that is not in the list. So that's our detecting phase. That's good. Now, finally, we're protecting. Now, the real thing. We have set the mode to protecting, and now we are blocking injection. We are blocking SQL injection. And here's my API is in debugging mode. So that will show me the actual error. So we can see that Proxy SQL will return an error, and the error text say firewall blocked this query. We can actually change that error description to anything else. So this is good. This is big success. And we can also test out our normal queries that we have trained. So this is okay. This is blocked. So now we can also test the SQL map again. And running SQL map will show this critical error, which is actually good for us. It means that this parameter, published parameter that we are trying to inject is not vulnerable. So we have created a firewall which protects us. Now, this is good, but it's not. There are things that we'll need to look for. We need to be careful. Whitelist-based firewalls by design are not smart. Pretty much everything that's not allowed will be blocked, even the valid queries. So if we will, for example, will request this website, this API, and specify published and author, that will cause the false positive. This is not the query that we have trained for, right? So this is a new field. It's also a combination of the fields. So whitelist-based firewall needs to be trained and needs to be retrained. The big potential issue with that is that if we have a release, a new version of the site, or the new version of the API, whatever, then we will need to pretty much retrain everything. So now what I will try to do is to give you a quick demo. I have created a very simple web interface for Proxy SQL as a proof of concept. And I have recorded this session. We'll see if it will work. So this is the web interface that actually allows you to see the status of Proxy SQL and to do some basic stuff. The reason why I have created it is that I found that it's pretty tedious to do the train phase and load phase and stuff like that. So instead, I will try to use this interface to do it by clicking the button. basically what I want to do is I want to collect the queries first, then I want to load them, and then I want to switch to protection. So let's go further. What I'm going here is I go to the firewall section, and then I change the mode to detecting. This is our train phase pretty much. So then I will go and visit all my APIs. We'll use the different endpoints just in case. And then I will reload this page, and I will see that the query digest has been loaded. Now I want to load that to the firewall rules. So I will change this mode to protecting, and then this interface actually loaded the firewall rules to the, it created the firewall. So now this works, but now let's create an injection. Let's see if it will actually work. Yeah, it is working. So now we try to do the injection and firewall blocked us. So this simple interface will simplify the work with a Proxy SQL firewall. So here's the conclusion. Always sanitize user input. That's a must, right? We don't want to trust our users too much. Use prepared statements if possible. It's a great idea to use prepared statements in any language. And then finally, use an SQL firewall or network firewall as an additional level of protection that can actually save you from something unexpected. If you want more information, then I have created this simple website, and we'll upload the slide deck there. So that's all I have, and we'll be very happy to answer any questions.